as I said, in terms of intents, those are objects that essentially merge in all the input data. So for example, when using a HTTP transport, when a request comes in, you can have data from three possible sources. You have the query string, you have the body in a post request, and then you maybe have URL parameters, right? So when you're actually writing a Thorin app, you don't need to know which one to use, because Thorin will just abstract this away and provide you with an input data, an input object, right? So even though you can say, okay, when /to-do/IP or /to-do/ID with a double quote, you know that the double quote and ID in the URL is a parameter inside the URL, but that parameter is going to be merged with the body and so on. So it gives you a single object, so you don't have to worry about any kind of other sources of data. This works well because when you're using the HTTP transport, it merges all this. When you're using the WebSocket transport, essentially it gives you the same object. So for example, if we have our to-do app using HTTP requests, it's very easy to just add WebSockets into our application. Just use WebSockets instead, because the input data remains the same, because the HTTP transport gets the data from the URL, and the WebSocket transport gets the data from the actual payload that you sent. So it kind of abstracts away all this part of the transport layer. Again, about authorization and middleware functions, those are kind of useful everywhere you go, so that you just don't duplicate your code. And finally, you have utilities. Thorin has some built-in utilities like file system utilities or sync utilities or series utilities and so on. Right, so this is just a bit of code where how the app.js of a Thorin project looks like. First, you just require Thorin, and then you say, okay, I want this application to use configuration from sconfig and give me this version. And then you say, okay, I want this app to work with a HTTP transport, essentially giving you the HTTP server. Then you say, I'm going to use the SQL store so that my models will be ORM, object relational mappings. And then you say, okay, my app is going to send emails. So I'm just going to use the mailer plugin so that I don't have to write all the email sending functionality. I'm going to say, okay, once you've done all this, I want you to load my path, to load all my libraries from this path once the framework is initialized. And then, okay, once you did all this, just run them, and then that's pretty much it. This is all your app.js file. It doesn't have 100 lines, it doesn't have, you don't define routes here because this is all abstracted away. So when your application actually boots up, what happens? When you require Thorin, Thorin will essentially look for its built-in sanitizers, and it will load them, and then it will load the stores. It will load your libraries, the transports, and finally the plugins. This is the way that we initialize our components. So in terms of booting up, this is the way we do it. In terms of lifecycle, where the first line here is when you require Thorin, it's going to prepare the environment, it's going to look for configuration sources, for example. By default, it's going to look for configurations inside the config folder. Then it's going to go to, if you want to add a different configuration source, it's going to get that one. Then it's going to register all our components, so essentially adding them and saying, okay, my app is going to work with these ones. When you call run, all the components get constructed. So for example, stores and transports have to be classes that extend a base class. And those classes are constructed if they're plugins, for example, or transport, or other type of libraries or functions, and the functions are going to be called. Final next step is to call whether or not we have an init function for each component. This is when you, for example, a plugin would like to extend the functionality of a transport or other plugins. When the init function is called, you know that all the components that your application is working with are there, so you can access them and you can extend them. And if you start the application, the Thorin application in setup mode, every single component will have its setup function called, if there is one. So this is essentially when you're building a plugin, or when you want to set up your SQL store, the setup function will set up all the things that the plugin is working with. So it's good when you're adding a new plugin, you just run the application with a setup argument. And finally, you have all the components have their run function called. This is an asynchronous function, so for example, the SQL store will try to connect to the SQL source. The transport layer will try to bind to the given port, and so on and so forth. Finally, your final function is called so that you know whether all the application is booted up or not. This is actually how a Thorin application launches. Now, in terms of the information flow, I've talked about intents, the transport layer, and all this stuff, but you couldn't, I'm guessing you didn't visualize it. So this is a way you can actually visualize it. The first layer, we have the client or the browser or any kind of other application that wants to communicate with our application. So it initiates a request. It can be an HTTP request, a WebSocket request, depending on the transport layer here. It can be anything, but currently we only have HTTP and WebSocket. So point one is where the request information reaches the transport layer, and then the transport layer gathers information from the request, so that, such as IPs or headers or any kind of transport specific information. Now, once it does that, it tries at step 2, it will try to validate the request payload. So in HTTP, this is where the input data merging comes in place, and it will try to create the actual intent. So saying, okay, you have, for example, in HTTP, the standard is you send a type and a payload object, right? So it validates that the object incoming has a type key and a payload key. If it doesn't have a payload key, it can get a default value. But in essence, it validates that you have the type key because Thorin works with actions. So it's required that the application knows what kind of action you want to execute. Alright, so once it merges all the inputs and creates an input object and then creates the intent, it passes that intent in step 2 here to the Thorin dispatcher. This is where the dispatcher tries to look in all your application's actions, all the registered actions, and try to match the incoming action with one of your actions. And then, if it has this kind of action, it will try to apply any kind of input sanitization on it. So you're going to see later on that when you define your actions, you say that my action is going to use first name is string, last name is string, email, you have an email, and so on and so forth. It will try to sanitize all this input for you. It will try to remove paddings and so on and so forth. And finally, it will send out the intent with the input data onto your actual action at the point at which your action will start executing middleware functions or authorization functions if it has registered. And once all this once it reaches Step 4, essentially your actual functionality and business logic is going to be executed. So this is where you will want to create an account, for example, or you will want to query for stuff. When an actual action is finalized, so when you do all your business stuff, you say, okay, this is my result. I'm just going to use it as the output of the intent. Sorry. So in most cases, the output is going to be an actual JSON object or an array or whatever you want it to be, and then just signal, okay, this is my output. It's whether it can be a success, it can be an error, and I don't know what it is, but I'm just going to send it back to the transport layer to let him figure out how that data is going to reach the final client. So in case if it's a success in an object, the HTTP and the WebSocket transport will know that it will just send out back the JSON object and apply the content type application/JSON. And this is essentially you saying you work with input data and output data. You don't work with any other kinds of things in between here. You get an input object, you output an output object. And the plugins and the transport are the ones that figure out how that object is going to reach your final client. Now, built in, the HTTP transport will essentially just send back JSON, standard JSON, of whether you have a success, a result object, or the error. Alright, so the current components that we have are, as I said, the HTTP transport. This is essentially a web server that handles incoming HTTP requests. Above it, is built the WebSocket transport, which uses socket.io and attaches to it an HTTP transport and essentially enables WebSockets in your application. The StoreSQL one uses SQLize to create your models, your database models, and it uses it basically abstracts away all the model loading and has some nifty things such as you give it a model and based on the properties of the model it will actually generate you an action, and you can generate a CRUD, create, read, update, delete, and find action just using this store. You're going to see later in the example. The next one is the Elasticsearch store. Again, it abstracts away stuff like connecting to Elasticsearch cluster or creating indexes and so on and so forth. Then we start with the plugins. The first one is a authentication mechanism that enables your application to log in and unlock. It abstracts away all the implementation details that you have to know. Then there's the password authentication mechanism where you have login with username and password, and the passwords are hashed and encrypted correctly. Next you have the authentication history, and this one works with the other two. So essentially when you log in and you want to have a history of all the attempts and login history of users, you can just use this plugin which works with the other two and just creates all your account history. Next we have the Discovery plugin, which is essentially a discovery model that enables your application to work in a microservice environment. Next you have the docs generators, all your actions, or essentially the routes. You can generate markdown files that document all the inputs that they use. This is essentially a very good thing for developers when just developing. Then there's the Geo plugin, where it offers you, it works with the GeoMine database, IP database that gives you the location of an IP. This is kind of expensive. It adds around like 60 or 70 RAM included because of the massive database that it works. That's why it's a separate plugin. And then you have the less and SAS plugins that essentially are preprocessors where they convert your less files or SAS files into an output. Then you have the loglet plugin, which essentially is a plugin that just pipes all your logs from application into loglet, or log mechanism, log storage mechanism. You have the mailing plugin that is essentially abstracts away all the functionality that you want to use when you send out emails to users. So you would use the mailing plugin and the render plugin, which essentially allows you to use the templating engine to output actual HTML data. So these two would work together to create the final HTML email and essentially have all the CSS included in style and send out emails without you having to do any kind of other things. Next you have the queue plugin, where essentially it works with the Redis store to enable you to have a queue mechanism in your application. You have enqueue and dequeue functions here. The session plugin also works with the Redis store to essentially enable sessions in your application using cookies and all that. Then there's a Stripe plugin where you can actually work with Stripe. So you have a plugin that implements payments for you, which is pretty neat. Next you have the static HTML generator. This is a plugin that essentially renders performs a GET request for all your actions, and if your actions are returning HTML, it will just store that HTML into a file. Next you have the tasks plugin, where you can actually create tasks that get executed once every couple of minutes or days or whatnot. Finally you have the upload plugin that enables and makes uploading files in your application easy. You don't have to think about limiting the file input and size and all those things. You can just set a configuration, it just works. And finally you have a plugin that gives you extended utilities. Now on the client side, we've created a small module called Thorin Fetch, which integrates with the actual HTTP transport and parses out the data, and it knows that how to send types and payloads and how to process the response. The same is done for WebSockets, for the WebSockets transport. Then you have Redux, which is essentially a small wrapper above Redux to make all this happen. And finally, as just a very, very small component called Tree18N, which is essentially internationalization for your client-side application. So I'm just going to give you a small example of use cases inside a real-world application. If you want to build a to-do application, you would use an HTTP transport as your web server. You would use the SQL store as your storage mechanism to create a to-do model, an account model, and so on and so forth. You may be using the plugin auth password to just have the username and password mechanism, authentication mechanism in your application. And finally, you can use the render plugin to just render out all the HTML that you want. This is currently it uses Nunjugs as your templating engine. So you would have, this is not for single page applications, this is for server-side render HTML. The next use case would be a mailing application. So again, you have the HTTP transport so that it knows how this is where it gets its input data. You would use maybe use the discovery plugin to essentially work in a microservice environment. You would use the email plugin to send out the emails, the render plugin to render them, and maybe you would use the less plugin to style those emails out. The next one would be just a simple CRUD application with file upload. Again, this is the default HTTP transport, SQL store. Then you would use the plugin upload to handle file uploading and then store them on Amazon. We currently have only the Amazon storage, but you can essentially create your own plugin to store them on Google Cloud or just a file system. And maybe you could use the docs plugin so that you have a documentation built out for you with all your CRUD actions. Let's say if you want to build a chat application, that means that you would need a WebSockets transport, you would need the Redis store to handle out all the session state of the WebSockets, You could use the session plugin to handle out the session of the user, the browser session, and maybe you could use the task plugin to, let's say, once every 5 seconds count how many users you have online. And then finally, the last use case is where you would want to build just a simple static HTML site. So what would that mean? Let's say you want to build, you have this awesome template from, I don't know what kind of site, and you want to change stuff in it, right? So you want to change how it looks, and that's kind of bad. It's kind of hard when you have like 10 HTML files and you want to have a single menu, right? So let's say you have 10 files, and all those 10 files use the same menu. So what would you do? You would have to go inside each and every single file to change the actual menu HTML. And what happens if you want to add another menu? You just change into them again. So that's, in my way, that's a bad approach. So that's why we built the static HTML plugin, where essentially you can use an actual templating engine to have your entire application divided into bits and parts and blocks, and you would have a menu block and then just create /about, create /welcome, /user, /login, /whatever, and all these endpoints would render out bits and pieces of templates that could extend a bigger layout. So you have one layout and you have one single menu, and finally when you've done creating all your endpoints, you can just run the static HTML plugin to essentially just download your application and save all the HTML files.
What template do you imagine you use?
We're currently using Nunjux as a templating engine, yes. We may plan to add support for handlebars or any kind of other templating engine, but we are currently using Nunjux. The final thing that I want to do is talk a bit about a case study. So as I said, this is the actual infrastructure of log.io. This is how we thought that it can work. So as you see, there are two types of actors. You have a user, which connects to the infrastructure by the web browser, and then you have Node.js applications that essentially send in logs to Logit so that they can be stored. We're going to start left here and talk a bit about the web app instance. Essentially, the web app instance is a small Node.js Thorin application that works with the HTTP transport and the render plugin to render out HTML. And it uses a bit of less just to essentially style out our application. This is where the JavaScript code of our single page application stays. And this is going to communicate with the Redis session instance here, so that when you go to /account, for example, it will give you the actual, it will check your session and give you the JavaScript file. If not, it just redirects you to the login page. It also communicates with the API instances, so that when a user wants to log in, it proxies the request to the API instance, which knows how to handle the actual user, and it knows how to go to the SQL storage to fetch the user information, and go to the Redis session to create the actual session, and then just finalize the request back. Then the user is redirected to the account page, and it's logged in, the session is there, and it can just go on with its web application. Now, once the user is logged in, it essentially sends out requests to the API instances, API log.io. And for example, if you want to create an application or create any kind of entity inside Loglet, the user sends requests to the API, and then the API uses SQL to store the information. It may be using the Redis cache to store various other information, and essentially just this is where you have your REST API. Now, once the user wants to query logs, so all the logs, actually no, let's go back to the Node app. So this is how a data is created within Loglet, user data or ORM data and SQL data. This is how, sorry about that. This is how data is stored and created when actually log data. So you have your Node.js applications that stream logs into a stream instances. So these are also Thorin.js applications that work with the WebSocket transport because between the Node apps, this is a WebSocket connection. It's just faster than HTTP. The only thing the streamer does is it goes to the Redis cache to authenticate incoming requests, and then just grab all the logs and put them in a Redis queue. And this is essentially what it does. Once they're put inside a Redis queue, we have a couple of worker instances right here, where essentially all they do all day is dequeue logs from the Redis queue. So it dequeues 100 messages, it tries to process them, and then just stores them into Elasticsearch. And even if any kind of event, like I don't know, your application is blocked, or you have an error, or any kind of other events that get triggered here by the worker instances, they can just send out a request to the mailer instances, actually the notifier instance, saying that, okay, send out an email to user X because this happened. And the notifier instance will just send out email, and that's pretty much it. That's all it does. So essentially we've talked about how logs are created, how they get processed, and then how they get stored. And the user, when the user logs into log.io, it essentially can connect to the API instances, and the API instances will query Elasticsearch for logs based on different kinds of querying mechanisms, and start date and end date and so on. And this is where, when an actual, so the live streaming, how we did live streaming is the stream instances that handle incoming logs. The first thing they do, they queue the log entry inside the Redis queue, and then they publish it via socket.io to a Redis channel, which the API instances are listening when a user wants to go to the live stream app inside their application. So when a log happens here, it instantly gets inside the user's browser because because of this channel, because the publish and subscribe model right here. And later on, maybe a second later, it gets processed by the worker. So this part here can be a bit lengthy depending on the actual load of the infrastructure, but your logs will always get in real time to the end user. So this is how we did a log.io, and this is why microservices are, in our way, the best scenario for handling some kind of this kind of applications, where you have 1, 2, 3, 4, 5 Thorin.js applications working all together, and then you have a couple of other storage mechanisms. But essentially, you can scale out based on where the load is higher. So you can have 10 streaming instances, you can have maybe 1 or 2 API instances, and maybe 2 or 3 workers, and just 1 notifier instance. This is how you reduce your cost and also have a higher availability. Because when you're deploying stuff, when you want to get your changes in production, what would happen in a monolithic architecture is that it would have to restart the entire application. So if all this was inside a single application, whenever you want to change welcome to hello, you would have to restart all the application, and all the connections will be lost, and essentially downtime would happen. But if you just want to update the email template, you can just deploy it here, and everything works as expected. Just this bit is going to have maybe a 1 second restart. I don't know. So this concludes the first part and the actual presentation of Thorin. If you have any kind of questions that you might find disturbing, or I don't know.
About the next part, what are we going to do?
Right, so the next part is going to be the traditional to-do application.
Okay. Can we do another one?
We can talk about it. Yeah.
The email one you mentioned.
Yeah, we can. We can do this.
I think it would be a bit more interesting than to do that.
Yeah. So we're gonna start. The second part will be we're gonna start with a small to-do app so that we can just get a grasp of what we're gonna do, and then we're just gonna build around it some kind of integrate other plugins with it, so you can have this kind of infrastructure right here. So this will be our small to-do app, and we're gonna have the notifier instance, and maybe we're gonna have the worker instance just to process our to-dos, you know, because we wouldn't want that. All right, so we're gonna have a small break, and then we're gonna come back and continue. Awesome.
Yeah.